Hello and welcome to Eternity Tutorials. Today I'll be dealing with linear equations in two variables. Let us first see what is an equation. We have so far learned about polynomials. So whenever we have an expression as x square plus x plus 1, this is so far is an algebraic expression or a polynomial. But when I equate it and I write down 0 or maybe some other variables on the other side of the equal to, this becomes an equation. So equation has an equal to sign and both the sides of equal to has the variables or the constants. Now linear. What is a linear equation? Linear means the degree of an equation is 1. When the degree is 1, then we say that the equation is a linear equation. Let me take an example. X plus 1 is equal to 0. If you see, the degree, that is the highest power of the variable, is 1. So this is a linear equation. If I take x cube plus x plus 3 is equal to 0, then this is not a linear equation because the degree here is 3. So this is not a linear equation. So whenever an equation which has a degree 1, that is known as the linear equation. Now what is the then two variables? We all know two variables. It is x, y, a, b, y, z. An equation which includes two variables as x plus y is equal to 3 or y plus 2x minus 1 is equal to 0. These are all the examples. These two are the examples of linear equations in two variables. Now, the number of variables decides the number of equations required to find the solution. If I have to find the solution of this particular equation, as you can see that it has two variables x and y. So to find out the solution of this, I need two equations, this and one more equation. Similarly here I have two variables, so therefore I need another equation to find the value of x and y. If alone I talk about x plus y is equal to 3, then I would say that this equation has infinite solutions. But alone this equation has infinite solutions, but because there are two variables, so we need two equations to find out the value of x and y. If there would have been three variables, then three equations are required to find out the value of x, y and z. Now let us see the graphical representation or the graphical solution. Let's take an example. I take x minus 2y is equal to 0 and 3x plus 4y is equal to 20. If I find the solutions of this equation, I see that x is equal to 0, then y is 0. If x is 2, y is 1. I similarly find out the solution here. I get 0, 5, 4, 2. Let us draw the graph of this. If we plot the graph comes out to be something like this. And if you see the intersection point, this is 4 and 2. So this becomes the solution of these two equations. That means 4 and 2 will satisfy both the first equation as well as the second equation. This is the graphical representation. But if you are not drawing the graph and you still want to find out the type of solution, let's see. Let us take two equations, a1x plus b1y plus C1 is equal to 0, which is a standard form of a linear equation. And the second equation is A2x plus B2y plus C2 is equal to 0. So there are few conditions. If A1 upon A2 is not equal to B1 upon B2, then the graph of such equations will be intersecting lines, and such equations will have unique solution. Unique solution means one solution. The second condition, if A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, then the lines will be coincident, that is overlapping each other, and the solutions will be infinite solutions. Third condition, if A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2, the lines will be parallel lines and there will be no solution. Now, three conditions. If A1 upon A2 is not equal to B1 upon B2, we say the lines are intersecting and there is a unique solution, that is only one solution. This will look like somewhat like this. Second condition, if A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2, then we say they are coincident lines and it has infinite solutions. Coincident lines means that if we draw the graph of two equations, let us say the first equation, the graph is this, and the second equation will overlap this. It will be somewhat like this. It could be this. Third condition, that if A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, the graph will be of parallel lines and there will be no solution. That means the two lines will be like this. If the lines are intersecting and coincident, that is, if they have unique solution or infinite solutions, then we say that the equations are consistent. But if there is no solution, then the equations are inconsistent. Let us take an example. If I take the equations, say 5x minus 4y plus 8 is equal to 0, 7x plus 6y minus 9 is equal to 0. Now we have to find out the type of equation or the type of solution these two equations have. Let's see, A1 is 5, B1 is minus 4, C1 is 8, A2 will be 7, B2 will be 6 and C2 is minus 9. Now we find out A1 upon A2, which is 5 upon 7, and if I have B1 upon B2, I get minus 4 upon 6, which in the simplest form is minus 2 by 3. Now because here you see that A1 upon A2 is not equal to B1 upon B2, so there is no need to find out C1 upon C2. And if A1 upon A2 is not equal to B1 upon B2, that means that we have intersecting lines. Or Let's say we have unique solution, or we can say that the equations are consistent. Now we have these two equations. We have A1 as 9, B1 3, C1 is 12, A2 is 18, B2 6, and C2 to be 24. Now I find out A1 upon A2, which is 9 upon 18 equal to 1 upon 2. B1 upon B2, it is 3 by 6, which is again 1 by 2. C1 upon C2 is 12 upon 24, again 1 upon 2. If you see, A1 upon A2 is equal to B1 upon B2. And C1 upon C2. Because all are equal, so we say that we have coincident lines, that is overlapping, or we say that the equations have infinite solutions. For which value of k will the following pair of linear equations have no solution, and the equations are given to us. Now it is said that these two equations given to us, they have no solution, and the condition for no solution is A1 upon A2 is equal to B1 upon B2 is not equal to C1 upon C2. So this is given to us. Now A1 is 3 and A2 is 2k minus 1. B1 is 1 and B2 is k minus 1. So we do not have to write not equal to C1 and C2, because from here we can find out the value of k. Let us cross multiply and I get 3k minus 3 is equal to 2k minus 1. From here 3k minus 2k is equal to 2, and we get k is equal to 2. So next question says, for which value of k will the following pair of linear equations have infinite solution? Kx plus 3y minus k minus 3 is equal to 0, 12x plus ky minus k is equal to 0. Now because it is given infinite solution, the condition will be A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2. A1 is k, A2 is 12, B1 is 3, B2 is k. If you wish to write C1 by C2, you can write down and equate any of the two equations. Let's say it will be minus of k minus 3 upon minus k. Now either you take the first two parts or the last two, or first and last, any two parts, equate them and find out the value of k. I will take the first two parts. When you cross multiply, we get k square is equal to 36. From here we get k is equal to plus minus 6. So that's the first segment of linear equations. If you have any doubts, please leave your doubt in the comment section. If you like the video, please share and subscribe the channel. Thank you.